Hi ladies, Mr. O'Sullivan. Today we're going to be looking at lesson 4-6, addition, subtraction, and proof. Just to give you the heads up, we use the addition and subtraction postulate when we basically are given information about pieces or whole segments and we want to go down a little deeper, or actually zoom a little out. So today's learning target is I can apply the addition subtraction postulate by drawing a conclusion based off of given information. The addition postulate states that if you add the same thing to two equal things, then the result will be equal. So we use the addition postulate when we're given information about pieces of a segment. So if I look right here, it says given AF is congruent to CD. So if I look, I don't have whole segments. I have pieces of a segment. So I'm going to mark those as congruent. What we want to prove is we want to prove AC, this whole segment, is congruent to FD, this other whole segment. So whenever we put things into statements and reasons, the first thing we need to write is our given information. So statement number 1 is going to be AF congruent to CD, and our reason is given. Now, if you look, if I want to prove AC and FD are congruent, there's a little overlap right here at FC. So I can say FC congruent to FC, reflexive. And then what we can do now is we can actually add these two tiny pieces right here, the AF and FC, and then the FC and CD, to get our whole segments. So this is going to be your final statement. I can say AF plus FC is equal to FC plus CD. Now, I can basically make this a little shorter. Now I can say AF and FC. Well, when I add AF and FC together, I get AC congruent to, and then I have FC and CD, so if I add those two together, I would get my whole segment of FD. And this right here is the addition postulate. And that's how you do addition. You do subtraction very similarly, but instead of going forward, you go backwards. So right here, subtraction postulate. It says if you subtract the same thing from two equal parts, then the result is equal. So you're always going to need at least two congruent segments or two congruent angles to then make your final conclusion. So if I look right here, my given is AE congruent to DC. So that's what I'm going to do as statement number 1. AE congruent to DC, and my reason is given. So I'm just going to mark it like this. And if I look, there's overlap. The overlap is right here at DE. So I can say DE congruent to DE, reflexive. And I want to prove that AD and EC are congruent. And I can show that right now. Because if you look, I have a whole segment congruent to a whole segment, and there's an overlap piece right here, DE. I can basically get rid of this segment, and I'll be left with AD and EC, which is what I want to prove congruent. So how I can do this is actually relatively straightforward. I can say my whole segment of AE. So I have AE minus DE is equal to DC minus DE. Let me make that a little tinier. One second. And that's equal to DC minus DE. So one thing that's important to know is that that reflexive piece will be on both sides of your equation, or your setup. So now I can make my therefore statement. So therefore, I can say AD and EC are congruent. And my reasoning would be subtraction. Okay, so now you're going to try these two examples by yourself. Try to fill in each of the following examples by yourself, figuring out if it's addition or subtraction. So if I look at my first example, I'm given AB and CD are congruent, and I want to prove AC congruent to BD. So I want to go from small to big. This is going to be an addition. So the first thing I'm going to do is I'm going to write down my given AB congruent to CD, and my reason is given. Now I see that there's overlap at BC, so I have to say BC congruent to BC reflexive. And now I can do my addition, where I basically add my two parts to get my whole segments. So our final step would be AB plus BC equals BC plus CD. Therefore, I now can say AC congruent to BD. And our reasoning would be addition. Just want to make sure the microphone was on. Now in our next example, we're given AC congruent to BD. So if you look, I'm starting with a whole segment. I'm starting with a bigger part. So I want to show AB congruent to CD. So I want to focus on that part of my image. So this is going to be a subtraction. So our first statement is going to be our given. AC congruent to BD. And our reason is given. And if I look, I have that reflexive piece right here, BC. So I can say BC congruent to BC reflexive. And that's what I'm going to be subtracting. So I have my whole segment of AC minus my reflexive piece of BC. And that's equal to my whole segment of BD minus BC. Now, by saying that, I can now say AB is congruent to CD. And this is by subtraction. And that is how you use addition, subtraction, and proof. If you have any questions, email myself or Ms. Colarundo.